for joining us today on the SEACAP for SDG training sessions. Today we are continuing the training regarding the Medecosur project and the outcomes that were selected to be capitalized on in the SEACAP for SDG project. Today we have with us Professor Marco Sala and Dr. Gisela Gargano for a later on presentation, but at first Professor Sala will be presenting us his presentation regarding energy retrofitting in educational buildings and specifically some case studies in Tuscany and also how this was accomplished through the Medecosur project. So thank you everyone for coming today. Thank you Professor Sala and Dr. Gargano for being here today. So we should start. I give the floor to you, Professor Sala. Thank you very much.
Thank you. Many thanks for inviting me in this meeting. And also very glad because in my experience as a director, previous director of Habitat Research Center, and also in my professional activity as an architect in my company, we developed many experience in retrofitting educational buildings. Mainly there are school second level, high level school for the province of Lucca. And this I go to share the screen with you. I hope so. Do you see? Do you see my screen? Okay.
Yes, we can see your screen, but we can see the Zoom link, not the presentation.
Oh. Now?
No, you must be sharing only a specific website. So maybe stop sharing and start again, selecting sharing screen.
Okay.
Professore, se apre Zoom, interrompe la condivisione?
No, it's
okay,
perfect. Now perfect. We can see it. Yes, perfect. Thank you.
Okay, perfect. Now it's better? Full screen?
Yes, but we can see also the next slide. So maybe if you go, I think.
Does it have to screen? Yeah, maybe. Okay.
Something like that. I think it's
maybe impostazioni di visualizzazione.
Yes, I don't know Italian, so one of these tabs is supposed to correct this.
Forse impostazioni di visualizzazione, che è sopra, proprio sopra.
Su uno schermo vedo lo schermo intero e sull'altro no, non so per quale motivo.
Noi vediamo pure le sue note, non so se non ha...
Lo vedo anch'io sul mio schermo principale.
Dico, forse da impostazioni di visualizzazione qui sopra proprio... Ok. Presentazione.
No, è una questione di zoom, credo, perché io vedo, ho due schermi, uno lo vedo a tutto scampo e l'altro no.
Ah, comunque anche così sì, non si vede male, cioè, per me può restare anche così, magari se chiude questa...
Adesso è lo stesso?
Meglio così.
Ecco, ora vado davanti con questo, davanti. Perché di più non riesco a fare.
Ok, ma anche quella di prima andava bene comunque. Per vedere quella.
Così meglio?
Meglio, no, sì, si vede bene, grande. Sì. Ok.
So, starting again, sorry for the problem. Okay. I will present some experience we have developed in Tuscany region in the area of Lucca province, which is close to Florence, of some schools. We start with this scientific high school Vallisneri, which is a complex of different buildings. As is usually been happening all over the world, I think, the school building is not all rise all together, but very often is an addition of different period, different type of building. We firstly approach this complex, and now next we will show you all the different interventions that we have performed in here, starting with the analysis of the existing building. And from this, we start with this one, which is it's a more modern building, because this one is the oldest. It's been realized maybe 60 or 80 years ago. Then it's been realized that this building, and that's the gymnasium. So first we started with this because despite it was more recent, but was badly realized. And the approach is to change completely the cladding, the exterior, to make a deep intervention to respond to the goals of the administration of Lucca. The goal mainly was referred to energy conservation, but also to the safety of the building itself against the seismic risk, because this is an area in Italy which is a seismic risk is quite high, as in Greece, I think. And the building at the time it was realized was not coupled the most recent achievement on this in this field. You can see on the left the images of the building. It was at the beginning. Is a precast metal structure which was quite common in Italy in the 60s, in the year 60s, and then has been totally retrofitted. Here you see the images, both images of the before and after the restoration. But let's start with the analysis. Analysis means to analyze all the aspects of the failure of this building from energy point of view, from the functional point of view, from the seismic response point of view, of course, but also from aesthetic approach. Because I think that making an intervention when the public administration decide to invest the money in an existing building to ameliorate energy response and so on, there is always an important aspect, which is how the building communicate this to the users, to the population, to the city. And so the aesthetic approach, how this can be interpreted, the technological performance is quite important, and especially it's important for the administrator, for the politicians, because it's the visual part that is more perceived by population. And this is the reason why we always try to intervene not only from a technical point of view, from energy point of view, but also to give a new image, a new skin that can transmit this to the normal people, to the administration. While I'm talking, I make running the slides. You see on the left side the previous images, and on the right side the after renovation image. When he started to analyze from the energetic point of view, as all the major quantity of building of that time was quite bad from the point of energy performance. Very, very bad because not enough insulation, because poor quality of windows and roof certification and so on. So quite easy to make a good intervention when you start with so bad starting. And after you can reduce very much. This I always show you all the images, and then we will go one by one to understand what they have done. From the point of view of anti-seismic response, the building itself was mainly lack of security control of connection between different elements. So we decided to improve with starting with I'm sorry, because it's not the proper. Beg your pardon, because it's not running. I apologize with you, but
Do you need some help, Marco?
no,
Or
there was a
something?
problem about the previous. I selected the wrong file. This is a file with a different approach. Okay. Can you still see the good screen? Okay.
We can see the case studies in Lucca district now. Yes.
Oh, this is the right file. So sorry for that. We started with the position of the building into the town of Lucca, and you see in the outskirts of Lucca. Here is the complex. Is the oldest part. Is the part in which we have started the first intervent, and this is the gym gymnasium. The images of the building is appeared before. The different parts and the different phases, because when you approach a retrofitting program, very rarely to start all together, but you have to organize different steps, and especially when you want to keep the function running while you are working, as was this the case for us, because the school was full of students, so we decided to make 3 different approaches. First, the anti-seismic response, then a part of the building with increase of volume, and then the other part. And there are the strategy that's been applied. Analysis of the previous building, seismic protection upgrade, new classroom, roof insulation upgrade, new windows, radiant ceiling, electric wiring and light renovation, new facade cladding, exterior solar sharing devices, fire protection upgrade, handicap accessibility. There are the different elements symbolized by the technical elements. And here is one of the first intervents. We decide to make intervents on the foundation by realizing a concrete ring at the base of the building, because there was lack of these elements, in order to connect very rigid all the columns of the building. Then, since the building has a steel structure, which is quite an easy case, because you can always intervene on steel structure. We may intervene by adding cross and bar to increase the rigidity of the structure, or to implement the dimension of the beam itself. Here you see some interventions from the outside, and the value that we was able to reach. The new facade was able to reach 0.24 watt per square meter, much better than the national rule that for this building is 1.28. And there are some details. How do we apply this? We decide to design a new cladding by adding components, different line of insulation, different properties, glass fiber, rock wool, and other plaster containment, and metal sheet to protect everything. Of course, the windows frame was high quality, double glazed, and all the detail explained. In the cladding, the final cladding outside was aluco bond with the aluminum surface, in order to have a kind of small ventilation under the outside skin. And when you arrive to the ground, use a different kind of insulation XPS in order not to be affected by humidity of the ground. Then standard technical opinion. This is the final image. You see, final image is totally different from the beginning. It's a modern building. About the aesthetic, it may be liked or not. It's not this aspect, but for sure, both students, professors, and the population of Lucca have the perception that the administration has invested the money in order to have a better school. There is a strong elements of controlling the soil radiation outside, because here there is the south facade, and the old elements give only an impression of a more modern structure. The base, the first elements are different color, not because aesthetic, but because is a more thick aluminium elements in order to prevent from damage of occasional damages. Here are the different elements of the school, different articulation. And here from inside, also the roofing has been changed because in the roofing we have inserted the heating system in order to have a radiant heat from the ceiling, which is very effective because you have the perception of the heat directly through your body from the head, which is the most sensitive part of the body during the winter. But also will be the possibility in the summer season, if I make circulate into the serpentine, which are under the ceiling, cold water or simple water from the groundwater, which is in standard 12 degrees, you may have an absorption of heat, which is not air conditioning. It's absorption of heat by the system of the radiant heat, that in this case absorb the irradiation of heat by the students and transfer to the heat sink to the heat pump. In the window frame are also present some elements in the window frame itself that can be opened. About this, in the beginning we was very confident of this system, but really in the results we have not was not so successful because these elements could allow to have a night ventilation, because night ventilation is all Mediterranean areas very important aspect. But one of the problems is that night ventilation allowed also to have elements from outside to inside, maybe insect or all other elements. You cannot leave the windows open, of course. So we try to have this mechanized or two sample elements that can be open or closed, can be facilitated the air circulation. It's not so effective because this work only if there is a wind pressure, because without wind pressure, even if architects make a lot of arrows to demonstrate that the air circulates, the air unfortunately do not follow the architect desire, but follow the building physics rules. And without the pressure of wind, this doesn't work really. So it's much better to have a mechanical ventilation that can be programmed, organized by night cooling in the early hour and in the early night, 3-4 hours in the morning. It is more cooler to refresh the building itself. Here you see some details of the elements in the roof that are transmitting the heat during the winter time. Also the lighting that has been modified, utilizing LED light with very low consumption integrated into the ceiling. And of course also the control about the distribution of light inside with some elements to control the distribution of light. But generally the light is not such a big problem because we are used and sometimes we are maybe obliged to follow the rules of the past time about natural light illumination. But today you have to face the reality that, especially in university, that most of the time people use computers, and having too much natural light affects the possibility of having a good view of the screen. And so this is one of the reasons to reduce the dimension of windows to the minimum that is allowed by the regulation, because there is no more such a need of natural light into the classroom, into the laboratory or the study offices of university and schools. Again, other elements, and here the elements of the calculation of the energetic need. We pass from 60 kilowatt hour to 30 with a CO2 emission, which is the half of before. You have to think that a building as a school and university has not the same value of houses, because they are used in very reduced part of time. School during the morning or morning afternoon, not during holidays and so on. While the houses, the number are more important because you have to live all the time inside. Another intervention was regarding the connection elements. You see these connection elements with a simple corridor that connected the gymnasium, this part of the school, the other part of the school. Also very same type of construction, very poor installation level, very poor comfort. And here we decided, for the same reason as explained before, to give also an aesthetic approach, to introduce some colors. And in order to not to seem too much a Gothic architects, but to take our inspiration from the past, we started from one of the most beautiful churches in Lucca, is something most ancient, San Frediano, in which on the facade there is this mosaic with beautiful color. And so, of course, there are some explanations that are very good to present the project to politicians and to clients. Architects have to also to couple their activity to this presentation. So we decide to utilize some of the color. Is an excuse, of course. In reality, we wanted to have a brilliant color in this corridor. And also with the use of the new material. This is a polycarbonate wall, cavity insulated wall. They are 4 centimeters thick with a lot of channel inside. There is not direct vision, but you have only the transmission of luminance. And here happen the very strange elements. These are the elements, very easy to be put in order. The aluminum profile, top and front. It can be up to 6 meters high, 6 meters long with these elements. But the one aspect that we haven't really imagined before, that when the building was finished and you walk inside, from outside you just see the color. It's also a very good element that make more pleasant and more friendly approach to the school. But when you go inside, it's totally different, because you don't feel anymore your location. Because before, this corridor have windows. From the windows you may see outside. And since the geometry is not orthogonal, but it is a different angle with the building, since you cannot see exactly where you are, the feeling of walking inside this is a very, how can I explain, you lose the perception of where you are moving. And this is an experience that has been appreciated, something kind of joke, like people moving from one classroom to the gymnasium, or from classroom to the other laboratory and so on, and given an even more joking aspect. luminance from the ceiling. But with these elements, you have also very good insulation because 4 centimeters of different cavity, you see the property of polycarbonate, you have very good thermal insulation comfort. So this aspect is not only a technical approach, but also effective reduction of energy consumption. At the end of the gymnasium, this was the standard existing gymnasium, very poor, also very ugly. We decided to approach it, but one very important aspect that generally is not always mentioned in this presentation, that there is not only application of the better solution. Everybody is good to apply the better solution. You give me all the money that I can use, I give you a wonderful solution. This is too easy. In the reality, you have to manage it with a restricted budget, because every administration has a restricted budget. So you have to couple the goal, you have to couple the intention you have in the strategy with the real quantity of money that you may use it. So you have to make some creativity sometimes. For instance, this gymnasium, you see, there was existing columns from outside. Existing column was exceeding the wall by nearly 20 centimeters. So this gives us the idea to make the new cladding over this column and to insert in the cavity insulation panels. So in the same time, I do not remove the existing, which was a costly of destruction, a costly of substitution. We have done in the school, but the school was different, was totally different, the facade of the school. But in this case, was not reason for spending money to destroy this part. We just add the new cladding in front of this and insulation in between in order to have a better performance. And from inside, we add acoustic panels, because generally gymnasium are very, very disturbing, acoustic disturbing spaces, because the students make noise, cry. So the acoustic component is very important. And the results is this. It's the same school. This cladding in the red color is also another approach to the aesthetic approach to make the difference between school and gymnasium. Here you make sport, here you make a relaxed through physical activity. So it's very good also to make the difference. And this is the thickness that we reach, because we add this on top of the elements that was exceeding the facade. And what is this one? This one is, oh, sorry. Since to intervene on the structural and seismic resistance of the building, we have done additional resistance structure in steel and concrete outside, very high from both sides, in order to block the entire structure of the building in the comfort of possible earthquake. And on the exterior surface, we make again, this is a sport hall, we make a climbing wall, utilize with all the elements that are used for sport activity, for climbing, with the safety rope and everything, in order to utilize also this system. To try to couple utility with the functionality, with the aesthetic aspects. And even this was very much appreciated from students. This was during one of the visits of Habitat Center, Master Habitat, that we performed in the past year. And now the third part. You remember, you have seen this one, you have seen this one. This is the existing the more ancient block, brick block school. First step, analysis. The analysis, the structure, we make historical brief control, how was the build at the time. We make a control also with the thermal camera in order to control the data from look area, the block. Different floor. The distribution was classroom, corridor, and services, and all the floor, classroom, corridor, and services, and so on. And we decided to make an approach to add some structural elements, as we had done in the gymnasium, to provide the resistance. And we developed with the engineers solution in order to increase the structural resistance. The input for the property was additional classroom, because it was not enough the number of classroom, anti-seismic performance increase, energy efficiency increase. So the first hypothesis to add some group of classroom with steel and concrete in order to give resistance elements that could provide a good resistance to the whole building. This is the new one, this is the existing. We developed the technology, dry assembling, and so on, the idea of contraventing with the steel structure, everything. The thermal performance was the most easy part, was not the problem. But there was a problem that at the end, after this analysis, there was not economical convenience, because there is a rule, as in every country, that in Tuscany, these rules, that if the cost of intervals by square meter is too high, in this case, with this 8,550 euro per square meter, is not convenient. It's better to demolish to make a new one. So all this analysis has been, of course, we have studied and been paid for this analysis, but the administration decided it was unuseful to spend all this money in this way. And so we decided to destroy existing buildings to make a new one. This is important of the previous analysis, the importance of the evaluation of all the possibilities you may have to give a correct answer to your clients, to the municipality, to the community. So this intervention was more. See, 1,173 was more than 8,050. So not economically convenient. So alternative intervents. These are the existing. Of course, the space is quite small, and also the access was important. And we decided to keep the access, to respect, and to make a totally new building very simple, very easy. Also because we decided to utilize as a structural technology, wood technology, cross-lam and platform frame technology. So the less is more. This is most important sentence, or even more important architects, remember. And we decided to make it simple, because the value of architecture is not to make very strange or very artistic performance, but to give the best answer to the requirement of the clients, requirement of the society. So utilize this intervention, and we designed a building which seemed a bit to come from the past. We decided not to have long, traditional long glazing windows, as in many after the Corbusier, many schools have this characteristic horizontal elements, but we don't need so much light in school areas. So we decided to have a single windows, very regular shape, very regular system. These are the elements of the new building, compared to the existing one. So it stay inside the dimension and also the distance from surrounding building. And the distribution quite easy, quite simple. Is the entry is a big entry with a staircase, but also a big winter garden. A glazed winter garden to bring some vegetation inside and to make intermediate space between outside and inside. Inside there is a two corridor crossing this way. Yellow are the classroom, the library, all the secretary elements, services. There are the upper floor, again classroom, services, these elements. You see, very simple, not without wasting space, without wasting money, without wasting materials, elements. This also is sustainability. And this is the idea to have this wooden structure that can be also be visible from inside. Unfortunately, this was not possible. I think it was a design from the beginning, but after we realized that there are so many equipment to pass over the ceiling, lighting, wiring, all the kind of, but also for fire protection, that having exposed the wood, as was our primary idea, which is quite good from the aesthetic point of view, because if you go into the building, they say, oh, this building is built by wood, and a building is exactly the same that another done by brick, and don't feel much excited about it. So what was the reason if I use a technology that I cannot see? But there are also technical reasons that do not allow to make this decision practical. But we try always to give some aesthetic or functional intervention, because having the corridor, of course, the corridor is a striped space where you have to move from one classroom to another. And we have also the pillars. But we decided to, not to have all these pillars exposed, to cover with these cardboard elements, different color. Each color is one different floor, ground floor, first floor, second floor. So to give an identity also. And also an identity by walking inside, because in this space, do you see, oh, sorry. Do you see this space intermediate from the two walls? Is utilized by some exhibition of material that the school has. This is an ancient school that has long tradition, so have maybe scientific instrument of 100 years ago, or some book they want to show, maybe some simple communication elements, and to utilize this niche in this space that we create by having this different angulation. And the walking through this corridor, it doesn't give you the idea of walking through a corridor like a prison, like you see in the movie Prison, or the sightseeing, all the things, the corridor and all the prisoners inside. Also, the students sometimes they feel there's prisoners being in the school. So not to add to this feeling also that the connecting spaces are so anonymous and inelegant. This is the approach of the school. You see, we try to interpret also the quarter in which the school is located, which is a outskirts of Lucca, built in the early years of last century. So a kind of a proportion between windows and wall, open and closed, which more give a sense of can you say of confidence. It's more confident approach. Doesn't want to be exception, doesn't want to be over the rules. Our rules are the entry, the two glazing elements that cover the elements of the edge. The structure is a combination of platform frame and X-lam frame, because it's a very quick system of construction, very good performance also in anti-seismic resistance. There is one maybe negative aspect that you cannot modify. But why you have to modify a school? The classroom, its remaining classroom. Sometimes also this aspect of considering the possibility of changing during the years is one of the many illusions of architects that are performed. Of course, the outside is covered with insulation of the different, with the structural elements, interior insulation, outside insulation, the coverage, final, the resistance, exceptional, very good transmittance of the structure totally. And this is the first images of the outside. The glazed facade that cover the staircase, the entry that invite you to approach this building. And from a technical point of view, we wanted to utilize deep exchange with the ground, but later on discussing with our engineers, decided that it was better to have a heat pump in this space on the top floor, and having a photovoltaic panels on the south exposed roof to alimент and to give electricity to a heat pump. Again, the detail of the staircase, and this element is not. This is a intermediate space of a winter garden. It means that it's not heated. There is not heating elements inside. And during the winter, naturally, it stabilizes to intermediate temperature between outside and inside the building. It means if you have a 0 degree outside, inside you have 20 degrees, this goes around 11, 12 degrees. And during the summer, you have to pay attention to make a lot of opening of ventilation. This is just an example of ventilation, because the air goes up and goes out. But in the reality, the dimension of the windows has been increased as much as possible, because we have a large experience on this building. We have performed on the first winter garden in the social housing in Italy, in Padua, many years ago, and we learn a lot about this. And the important is to over-dimension the openings and to make it openings automatically all electric, in order to have a control during the summertime of the ventilation real, follow what you have in mind, not only because you have designed a red arrow or blue arrow. And it's again the approach from the street and the corridor that became a symbol of this structure. There are economical aspects, and also from economical point of view, to have done a very regular structure allows you to have also a good performance from economical point of view. Another very simple, very small and very simple intervention retrofitting is a garage near the seaside, another school. Here the sea, the school is a big building, always realized during the 50s, 60s of the last century. Quite a big intervention. In this case, this charter started this retrofitting, and the reason of this intervention was quite easy, because if you see this crazy facade, absolutely stupid, absolutely crazy, because what is need of all these glasses? What is the need? I don't have plans I have these are secretary office, they are the entry. But all these offices, they put elements to protect from the sun in summer. In winter, it's freezing because there is not enough value, insulance value to keep the comfort. So absolutely was a unuseful space and very much related to the time is a wasting of money, because when you realize this kind of solution, you make not the interest of the clients, you make the damage of the clients. So the answer is very easy. We make insulation, we reduce the windows, we add the thickness because the insulation in this case is quite important, 20 centimeter insulation. And the activity inside is exactly the same, much better, because all the port secretary that you have to work on a computer with all this glazed facade was a terrible task, while this is proportional. You have to control it. This was the rendering of the proposal. And sorry. There are the very bad quality picture because of the training. You see, just add the insulation, you cut, you add the insulation, then you make it the plaster of the different status, the thickness and two kind of insulation, the resistant elements, and the final cladding. And this is the results. Change the approach. You see that the school has changed. This is not this is the reality. But maybe the color is more thick, but you have given to the school a comfort, a reduction of consumption, reduction of air conditioning in summer, reduction of because there are offices, reduction of heating in winter, and comfort for working people. Very small, very simple interventions, but sometimes, again, I remember you that less is more, sometimes small is beautiful. Less is more, you know, that the important architect, the less is small is beautiful is another important architect. Been a very close friend of mine. Is an architect from Greece, Alexandros Tombazis. That was one of the inspirators of this sentence. And now let's pass to another big institute, a big complex of buildings, always in Lucca, the Carrara Institute. All this project has been carried on firstly with the Habitat Center, researcher of other colleagues of Habitat Research Center, which I was the director until 4 years ago when I get retired, and then realized with professional activity that they've been in charge to do it to complete. Again, we are in Lucca. Here there was the area of Valisneri. Here the opposite side. This is the big complex, and even in an important position because Lucca, the marvelous town, one of the few towns in Europe that remained encircled by the city wall. One of the most beautiful. You had the chance to visit Tuscany. Don't miss to make a visit to Lucca. And this school is just in front of this wall. So there was under the control of the rules of superintendence. We call the offices that control the relationship between the new changement and the artistic beauty of our country. And it's a very big elements done by 4 different buildings connected together by front elements of corridor and connection. So here are the wall, the city wall of roof. Again, we started from the analysis. We started to understand what is the problem. The problem was very easy because even without looking at the thermographic control, you see very well from the picture what kind of old-fashioned architecture remained, misuse of concrete elements, because the concrete, when you use in small dimension, as it was the small pillars of the facade, is very much affected by corrosion, because the steel inside is attacked by rust, and the rust expands the material of the steel and disgregate the concrete. And so these are the typical elements of disgregation of all the elements in even bridge, unfortunately, even bridge. So the result given by the thermocamera was a totally lack of heat containment. There is a like being open air. You may put the heat inside, but the heat goes outside. So first problem to reduce heat consumption in this building. Here you see very well. These are the elements of the steel that have been attacked by the rust, and of course also the safety against the seisma, because if you lose the combination of strength by steel bar and the concrete, you lose the strength of the structural elements. So there is a very dangerous around it. This also see, this is the lower part of the window, and in the thermographic you see how it's been built. There are the block, the masonry block, and you see the difference of color, because there are thermal bridge where there is the connection between block and block. So it's totally failure of this facade and need to be protected. Here, this is the interior. From the interior of this classroom is the picture. You see the wall, all the brick, and then you see all the thermal bridge, because the humidity affects the angular elements to the thermal bridge, and then all the disgregation elements of vegetation across. You see again all the elements. So we have to face a very important problem of conservation and how to control. So first idea discussed with the engineers was to couple a resistance elements, this is red, outside the building, resistance elements, new in concrete and steel, to make also this part of the floor, of each floor, new in order to connect these elements. And so these elements could be the resistance elements that avoid the building to collapse in case of earthquake. These are two because it's bigger than the earthquake. These are similar. These are the first approach. These are the front, this is the gymnasium. Even this has been divided into different steps, because first of all, for economical reasons. Secondary, because we have to keep the activity, didactic activity during the time. And so this was the first that we have been approached. This is the second and this is the third one. This is explained before, the elements that have been totally renewed at the floor between the two resistance elements. These are the technical drawings. And outside elements we decide to design in the concrete as traditionally was done called the barbicans, elements that try to contrast the movement of the building, to give it also through its shape, to give the strength, necessary strength to the elements. We also decided to close some windows because there was too much windows, to close some windows and to modify this existing window to enlarge someone. And the combination of these two elements give enough strength to ameliorate the performance of the building in case of an important earthquake. So here again you see the elements. From the front, the original idea was to have some color, to have a different approach to the corridors closing the front to the wall. That is different. And again, how to design these insulation elements? Not only this way, but to cut in order to allow the light to arrive better inside, also to see outside better, and also to have an aesthetical approach from outside. It's not just simply doubling the wall because I add 30 centimeters of insulation. It's too simple. This is the basic idea. With this system, by utilizing this 20 centimeters, we totally control the thermal bridge. Doesn't exist anymore, the thermal bridge before, because these are the elements that protect all the outside elements for the facade. And the light from outside, but also the view from inside is strongly ameliorated if you have this closed instead of having this cut. Of course, to have this performance, we have add a bit more dimension of insulation, because otherwise, if this was the standard, this was too less. So we add 5 centimeters more to these elements that are closing the building. Here you see the building from outside. What is this is the boulevard. On the right side there are the city wall of Lucca, historic city wall of Lucca, brick, and this is the new. These are rendering. This is the new facade with these elements and with the color in the corridor in front. But first of all, this is a rendering because the control over the relationship between the new architecture and the existing one didn't appreciate our initiative about this color, and so they don't allow to make this intervent, and so we remain without this new color. But this has been approved, has been realized. Again, this is the rendering on the corner, the approach, the new design of the facade, and which is not done in this way, but anyway. And when he presented this, even in town, has been started a big debate. Some local newspaper, but the appreciation was much more than the criticism. And even if in Tuscany, in Italy, in Tuscany, criticism is a very strong approach, and even in Lucca, very high. But the population is appreciated because it looks something new, and looks something very different from this old building was not at all. And these are again the rendering of the complex. Yeah, the city wall done in brick. This is an important position. So it's also correct that this control about the new intervals. Different view from the back, nothing the back. And this is the reality. This is the building realized. This, you see, it very much look like the rendering before. This is important because it's not easy to realize a building with all the constraints, all the difficulties to make difference between theory and practice. In Italy, there is a popular sentence to say, fra dire e fare c'è di mezzo il mare. Between saying and doing, there is the sea in between. It is much different. In this case, we were able to realize. Not in this part. These are the strength elements to make rigidity for earthquake. In our idea, and maybe you see some, not very much. You see in the rendering, there is some green, because the idea was to connect the two concrete wall with the green elements, suspended green elements that give a more pleasant approach. But the administration didn't appreciate because they estimate that maintenance was too heavy, they could give a problem. This is a pity because I think that this was important to have these green elements as a signal. So even easy to make kind of plants that can grow without much care about the people. For the rest, nothing to say. It's worked very well. The inside the students appreciate the quality of interior space, both from luminance aspect and from elements of the acoustic inside are correct. So it's been a successful element. These elements in front has still to be done. It's under construction now. There is on this work. I'm told that they have been in charge to perform the whole complex. We have suffered a problem the last year that due to the excessive rise of the cost of the building material that in Italy partially has been provoked by the international fluctuation of cost of material. Many China that intercepted much raw material, but mainly because in Italy have been approved bad legs that allow people to spend money to change the cladding of the building to get reimbursed by the government. And this has provoked a running of the public money, and in many European countries quite often happens. And this make rise so much the cost of the material, the cost of the labor, that for 2 times the tender for the company to realize the other part of the building has been deserved. No one presented because the cost, according to the idea of the constructor, was too low. Now we hope that from one side the province of Lucca found additional funding, and the other, it seemed that this horrible tendency to profit out of this situation is changing it, that the cost could be lower, it could complete. Otherwise, it would be useful to have one part and the other the same way. Yeah, again, some detail. And this is It's a very good technology. You see, there is no more elements that are surrounding the windows. There is no more elements here on top. Everything is covered with the same insulation, with the same plaster and resistance elements. So you don't need additional elements to make this. And what doesn't exist, it doesn't cost. Okay. So the cost of this facade is also a contribution of different aspects, different approach. Inside the building, we have just to make a new plaster. Now we have the ceiling is has this false ceiling because in this element is contained a new luminance and new radiant heat. Before the original level of the floor, the ceiling was this one. This has been more lower to hospitate to host the heating in the elements. And then the last elements, the Majorana, which is another again in Lucca, near Lucca elements. Again, in a complex of different building school, all make part of this school complex. They decided that they need to intervene on these elements. And again, these interventions has been divided in different steps because it was not enough to start all together. This was the existing part. First step, just to add a simple group of classroom. Very traditional construction, very simple block, insulation block with insulation again, the pillars, new frame windows, and so on. Radiant floor, this time not radiant heat, radiant floor, in order to separate from the ground also. Standard concrete structure, all to reduce the cost because aspect of costing would be, as in every building is pretty important. And this is the first step. Very simple. The color, I don't totally agree with this color. I prefer to have a brilliant red, but this time the administration was not accord. Then second step, to add another floor on top of it, to add a glazed elements to connect, and to have a double roof to protect from the hanging, to protect from the sun, and to avoid the direct radiation over the roof of the building. Here is the intervention of the first floor, and an interesting approach about the ventilation. Here you see very classical layout of classroom facing south, a big facade facing south, corridor north side. But if I open a window here, I have a very small change of air inside. So we decide to have some connection over the corridor. The corridor has a ceiling lower high to connect directly with the northern facade. In order to, if you open the both opening, you have a cross ventilation in the classroom. You see, this is the corridor. The air comes from outside to pass into some tube, and the ceiling is in this position, and can arrive into the classroom, and then go out from the top upper part of the windows. These are the roofing of the double roofing, metal double roofing. And again, this is the structural elements. You see the passage of air, this is the function to control solar radiation. In reality, we have to add also an exterior sunscreen because these elements was not enough extended. To be more effective, you should have maybe 1.5 meters, maybe 2 meters, to exceed excessive long. So we decided to provide an exterior sunscreen to protect the facade. That is the rendering of the images. And then this is the additional staircase just in case of accident. And this is the double layer glazed elements is the entry and the intermediate floor that allows students to see people from different heights. And in reality, this second floor has been done in different way, not with traditional brick, but with steel frame, light steel frame, cardboard, insulation inside, acoustic and thermal insulation. And this is much simpler technology, much easy, but allows also good performance in acoustic performance in one classroom and the other, and very quickly, very clean as a work and not vast of materials. During the construction, we directly apply over the concrete of the floor. And here are the structural elements that allow to have the double cover over the roof that protect from direct radiation. And here is just a joke as the image of the scanning keys from the computer, from the smartphone. We have used simple and cheapest tiles, black and white and dark gray, to compose the kind of image to be screened by smartphone. Here is the school. Only thing that I'm really disappointed because I was not able to make the direction of the work directly. In another people from the province of Lucca, they decide to have this horrible color of this aluminum cover. White. I wanted to have a brilliant red color inside of this brown horrible color. This is not facade. And in this case, you don't see the element of the ventilation because this is a ventilated facade under this color. And this is the light cladding of perforated steel plate in net, metal net, to close to masquerade the fire exit emergency exit. There are some other images. Again, these elements, which is the connection and the entry, we had done again with the polycarbonate for problem of cost. In this case, not colored, but just white. But it's an interesting approach to, because it is a corridor, intermediate space. And so the insulation provided by the polycarbonate carbon polycarbonate was enough to give the performance. These are glazed doors, and the good elements of connection between the existing building and the new building. And you see very well that the overhanging is not enough to protect really this facade. Should be a meter more, but much easy to take outside window frame to have this done. But maybe I could have some more time. Could add an element. Not a school, but it is a factory of incubator different companies performed in Lucca. It coupled different technology together. That's because it's one of the maybe more iconic building we have designed in Lucca. And here you see from this facade a different approach. This is a south facade. The south facade is a combination of windows, of course, and opaque elements. Opaque elements are covered with the photovoltaic because it's a vertical and south facing. But the most interesting element is not a simple windows, but inside this opaque part, there is a different layer that can slide in front of the window. And according to the climatic condition, you may have a double window, you may have a solar screen, you may have a mosquito net, and so on. Then you can modify the performance of the window, the opening, according to the desired condition. Then there is a corridor of these are the building. There is a corridor covered with glass. You see, these are the south windows. There is a garden over the roof of the laboratory. These are the elements. These are the elements. The project. These are the connected. Each element is a company. There are nearly 70-80 square meter. Is a small company that they rent the space. They have all the services furnished by the ruler of this project. They share the services, and they share this big greenhouse, this big winter garden that gives entrance to all the elements. This is the first floor with the garden on top of a laboratory elements. There are some slides of the open over the winter garden. Some analysis that reflects the correct. Yeah, there's a section, the garden on top, and the winter garden. And have some elements during the construction. And the first approach, of course, the foundation, but It's not the foundation, the interesting. Interesting is on this thick tube, because the first elements has been to dig 18 deep wheel, with 80 meters to make exchange of the ground, to make a heat exchange with the ground. These are the first elements to be realized. Here during the construction of the glazed roofing, the entry, the glazed roofing. This is the same principle of the facade with the opaque elements that contain different layers to modify the performance of the windows. But since this facade is exposed to the, not to south, but to the east, the opaque element is covered with glass, could be marble, could be brick. It's just an exterior decoration, not really function. The function is inside. The performance of the facade. Here is the elements of this window that we have developed with all standard elements. All these components are decided to utilize Shuko, but we could make Poppy, we make Metra, any kind of big company we produce window cladding. But with the same element, without make any special elements, we combine it together in order to have this performance. Of course, we have realized a prototype before. This is the prototype realized in the factory. And, this is not the real PV, just a glass, since it was a prototype to control the element and the passage of the elements. And in the performance, it demonstrates that has a good impact also. The red color, I like red color, like the red color, red Ferrari, like the Brembo, like a lot of, is a communication color. And in this case, they indicate the laboratory and is a lower part of the garden, after garden. And inside of the glazed corridor. The glazed corridor has a huge balcony to give access to the offices, and just to increment the light around inside, we make the pavement in glass. Of course, not transparent glass, but not to see the legs of the ladies, but to let the light arrive inside. It's making also a very beautiful effect. And also the shape is not, again, is not to have I call prison feeling, or having tried balconies is curved, and the curves are different on each floor in order to help ventilation, to help light passing through. The top of the building is glazed, the house is glazed. There are some photovoltaic into the glazing. Is it useful? Very poor, because the quantity of photovoltaic is much less if I have a wall panel. But this is a communication. This is important because everybody goes into this gallery, raise their eyes, look at see this roof, say, oh, there's photovoltaic in this building. Because today photovoltaic is not only a powerful way of producing electricity, but also it represents a concept, communicate the concept of sustainability, the concept of being update to new technology, and to give this idea. And for this reason, we we applied photovoltaic in a normal roof in standard way, but we wanted to apply also here just to give this feeling to everybody who got into this scooter. Ora non posso, piano per 10 minuti. Some elements during the construction with the shape. Even this shape, you may say, oh, what's nice shape, what is aesthetic, artistic architecture. It's not only a matter of being artistic. These elements with this line is because on this surface we have openings to ventilate the gallery, and in this way the rain doesn't come in. Here you see that this ventilation, while this is sealed, the ventilation is here, but with this hanging doesn't allow the rain to get inside the building. This is during the construction. This is the luminance. You see the effect of the light arriving here into the gallery. Here the garden. Inside the garden, there are also these elements that allow the light to go in the floor and of laboratory section. In the middle of the garden, there is a tree, olive trees. Olive trees because Mediterranean, because the symbol of peace, the olive trees, but also because under these trees there is a crossing of beams and there's a pillar. So it's the most logical place where to put the additional heavy charge over the structure. So not always is aesthetical is approach, but also as a reason. And during the day, people from offices came here to have to smoke a cigarette, to have to eat something, to see the countryside. From here you see the city of Lucca in distance, you see the mountains. Very pleasant for everybody who works in this complex. There are other elements to make some ventilation. And the consumption of traditional building is quite high. The consumption of our building is very low. This building has been published in magazine and book because it's a kind of concentrate of technology. Every year we make a visit of our master class in Florence, because thanks to the administration, thanks to the Commerce Chamber of Lucca, we was able to introduce a lot of innovative elements, but always without surpassing the budget that was assigned for the building. This is very much important because to make good things with a lot of money, it's easy. To make good things with less money, much less. Thank you for everybody, and I keep waiting if you have any question, any curiosity about the presentation.
So thank you very much, Professor Marco Sala, for your presentation. And of course, the opportunity that we had to see some practical examples regarding rendering and the presentation and how these kind of buildings are shown in this kind of programs. If there is a question, at this time, I think it is possible to have some. I think everyone understood everything perfectly. I want to ask if you had the chance over the years to run the simulations differently, the rendering differently for the same kind of building. For example, you mentioned about the openings and the windows and how the light is reflected. But over the years, some changes have been made to our natural environment and also to the surrounding environment of the buildings. Have you had the chance to differentiate from your initial path, from the initial structure of your proposal?
Well, the performance of the building, of course, that can be measured, that can be controlled by the designer, but are also matter of the management of the people who stay in the building, work in the building, and this affects very much the final results because sometimes you provide some device, people don't use it, or they use badly. So sometimes it's a complex matter because there is two different approaches about this. One approach is to make people responsible for their behavior. It came from the school of thinking from England of adaptive comfort. Adaptive comfort means that everybody in their own environment, if is able to modify the condition, the boundary condition of their environment, they feel much comfortable. And feeling much comfortable because it depends from their own decision, bring them to accept physical condition much different from the standard normally required from comfort. And this is one direction, one way of thinking. The other approach is that people is idle, people don't understand things very good, use badly the tools they have to modify the performance of their envelope. So they tend to criticize. So it's better to give them everything automatically controlled. You see, the really opposite approach. This is worthwhile for temperature control, for lighting control, for many aspects. It's not easy to give an answer.
Okay, thank you very much. So I think at this time we can thank you first of all for your presentation and your work that you have showcased with us today. At this time, I think if there's no other question, we can have a small break for 5 or 10 minutes, and then we will continue with the next presentation. I notice Professor Tropadore has joined us as well. And Dr. Gisela Galgano is still here, so thank you very much.
Yes.
So maybe we should have a short break for 5 to 10 minutes. Like it's a 4:45 CT, so maybe 5 minutes till 5 CT. We should be back and continue with the rest of the presentation regarding Metecosur and the steps that need to be taken within the toolkit methodology. So thank you very much at this time.
Yes, thank you. And we really would like to say thank you to Professor Marco Sala for
joining us today.
These real case studies. Thank you very much.
Thank you very much.
Gracias.
Hello, good evening, Professor Tropadore. So we're getting back from our small break and from the presentation from Professor Marco Sala.
Marco Sala.
Yes, exactly.
Yes.
It was a fruitful presentation, and he showcased us some examples and some case studies in Tuscany as the first part, and guarding rendering. I'm sorry. and how this can be done, and some basic example that he has implemented this kind of methodology. So at this time, we should continue getting back to the medical sure outcomes and the medical sure toolkit as a solution that we have been showcasing in the last few sessions. And as this method said, we should continue with now the fourth step of the retrofitting solutions. That is the intervention, correct?
Yes.
Okay, so
Yes.
Professor Topadora, you will be doing the presentation, or?
Yes, let me share the screen.
Mm-hmm. We can see your screen.
Yes. Okay.
So you can start. Perfect. Thank you.
Yes, we prefer to introduce today Professor Marco Sala because he's a very long experience in this. So it was the director of Research Center of Habitat. So it was my director for many years. So I think his experience is very interesting for us because in the intervention, so during his activity, he was able to follow many interventions. The intervention phase is a very particular step in the process of building because there is the physical effect. You can see the physical effect of all the previous steps. So it is the moment, it is the phase when you can control, and especially to have a really perception and evaluation of all the decision, all the selection that you have done before. So the intervention is really a key phases in this way. But our question is how the Living Lab can improve this kind of activity, because generally any activity are promoted by the public administration following some rules. So in which way is possible to implement additional activity, introducing some didactic aspect or dissemination activity, transforming the experience of the intervention in a best practice. And in a really pilot project where it's possible to investigate if the solution, if the scenarios are really effective in the specific site. So according to the renovation approach, the phase number 3, so the renovation process moves to the construction works. So it's not only a planning, but now you have to decide and to combine your experience with the really capacity of the construction company to realize the idea. Delivering the renovated building in order to be monitored after in the post-management phase 5. So it is a medium, it is the core of the not only design process, but the retrofitting process. In this way, the set of activities spanning from the approval of the renovation project to its full realization throughout the construction works to the physical renovation, the existing building. Of course, thanks to the integration of the select mix of technologies. In this way, the retrofitting construction works are generally more complicated than the others. Why? Because insist on the existing and functioning building. So sometimes you are operating in an university building when you have not the possibility to close everything. but maybe you have to divide the functionality of the building, so reserve some space and some classroom to the typical activity, to the lesson and research activity. So sometimes you have to combine the building site with the normal activity on the university building. Another element is the construction site can be partially occupied. So it's very difficult to define the space for the machine, the space for the movimentation of elements. So it's very important to plan the building site in a very effective way in order to allow the combination of different functionality. Because sometimes it's not possible to interrupt the work, the general activity. Otherwise, you have to move the training activity, the research laboratory, and so on in another place. So this is one of the typical difficulty to work in the envelope, otherwise in the planning side for the changing the energy fitting and so on. And the time is a critical factor. So you need to plan the building site in order to combine the different activity of intervention, evaluating the technical feasibility, considering how many time you will need to implement this kind of work without implementing the cost, without any additional cost. So this is a verification that you have to do before to start with the intervention. What about the people involved in this kind of phase? Of course, the researcher can support the evaluation of the tender. As I mentioned before, in order to assign to the building company the work to do, you have to cross the phase of tendering. And generally, as public administration, we have to do a public tendering. So in this way, the research could be supported in order to allow the quality inside some specific element of the tender. Because generally the company will propose some reduction of cost, but proposing some different solution. So in this way, it's very important to fostering the quality. But there is another very interesting activity that during the intervention, the research, maybe with a student or with the other, with the company as well, can document and valorize the implementation of the renovation, collecting video, creating some opportunity some storytelling of the intervention phase, and collecting this, transforming the experience in a very best practice of the pilot project. The company as well can provide material for the construction. For instance, it's possible to allocate in the living lab some example of the innovative material that will be applied in the construction phase, or some little part of PV photovoltaic elements. So creating like a showcase, like a showroom inside the laboratory of some part of the technological solution present in the intervention. The student can they can benefit, they can take some experience assisting, you know, so have the real experience in their university. Because generally the training activity is only theoretical. So in this way, they have the opportunity to assist and to have a real experience and to follow day by day the incrementation of the intervention. So execution and construction. Before before the construction, as I mentioned, there is the tendering and commissioning activity. So the selecting of experienced, competent professional and contractor, it's very important to select because they will work on renovation of the existing building. And it is a very crucial activity to allow the very successful result of the retrofitting process. For the public works, the activity regarding the foreseen formal and structured procedures for generating competing offers from different potential suppliers. It's very difficult sometimes to do only for the technical office of the university. So in this way, it's very important for the research and for the other team to support in order to organize a very good quality, good description in the tender of the different performance of the technology, suggesting some indicators, to allow a good evaluation of the different proposal coming from the companies. Of course, everything has to do in the framework of the national and local requirements by law. So now, especially in Italy, there are different opportunity for the tendering presentation. It's possible to present a tender only reducing the cost, but also there is the opportunity to present the similar cost, but introducing some innovation and some additional activity implementing the quality of the building. So we have three basic forms of procedure: open tendering, selective tendering, and negotiated tendering. The last one is the typical negotiation, where it's possible to discuss with the company maintaining the similar cost, maybe to introduce some innovative element of other solution, much more better than the proposal, the first proposal. So it is, I think, more advantage for the public administration and for the university introducing this kind of negotiated tendering. And the tendering could be carried out in one single stage on the two stage. So it's according to the level of complex, how many technologies, so according to the budget, maybe it's possible to divide in one step or two steps. According to the national law, it's possible to create many documents. So it is a very particular activity where you have to prepare and to collect administrative document, technical document, sometimes a financial aspect of the company. So it's very important to create an interdisciplinary team. So in this way, the Living Lab could be very interesting in order to organize the meeting, to specify, discussing with the company that could be selected or they are interested to participate in the tender in order to discuss the specific requirement of the project need to do a better offer, an implemented offer, so implementing the quality of the result. In this way, of course, it's very important to define with specific details the renovation project, like many annex or many sheets specifying the performance of the proposal technological mix, in order to facilitate the company to present a very good offer. According to the dimension of the renovation project, the document can contain technical drawing, other elements with much more specification about the solutions. According to the complexity as well of the renovation project, it's possible to introduce commissioning process. Generally, it's not so. Generally, you have the opportunity to select a commissioning process or not. So it's not mandatory. You have the opportunity to present or not, so to implement this activity or not. We suggest to introduce because it's another phase to control the quality of the process. Because in this way, it's possible to carry on an engineering process to check, to inspect, and to test every operational component, controlling that all system and components are designed, installed, tested, operated, and maintained according to the operational requirement. So you have an additional step, an additional activity, very useful to verify the quality of the project. In this way, from the constructor to the owner, it's possible to guarantee all the process and to guarantee the achievement of the performance, but also the reliability, the safety, and the information also checking and searching. And what about the Living Lab? Also, in this phase, the Living Lab could be very, very useful for the interaction of research that can propose innovative example of tendering, so introducing more qualitative procedures, not only for the discount, but as I mentioned, to implement the quality. For the building manager, it's very interesting because they can organize, launch, and evaluate the different kind of tender. So the building manager has a very good support to create a good decision support system in collaboration with the researcher. Of course, it's a very particular activity, the involvement of the companies, because according to the national law, there could be an interaction. So it's very important to define in which way the suppliers and the company involved in the construction can be participated to the tender. Generally, as public administration, we can collect 3 or 5 offers to the tenders. Otherwise, it's not possible to have a direct contract with one single company. So in this way, in order to organize a better contract, of course, you need to follow all the national procedures. The execution and construction of the pilot is a very important activity. No? There is a very good visibility, so it's very interesting to emphasizing this kind of activity, allowing the people to have a very nice experience of this phase. So the execution is very delicate, so it's very important to avoid the risk for the people that are in the same building site. In this way, we need to improve during the design phase the correct installation of the different machine and movimentation of technology for the execution phase. So it's during the normal activity of university. And again, the Living Lab could be very useful because researcher can organize several events dedicated to the student. So in order to stimulate the participation and the engagement of a student, not during the real activity, but looking and searching and investigating, so taking some experience in the visualization day by day of the process. For the building manager, the team, it's very useful, of the Living Lab, it's very useful to implement the supervision activity. So for the assessment, for the control of all the steps of the intervention phases. The student can participate in education event, and for the company as well, it is a very good opportunity to have a like a showroom, so a very physical exposition of their best technology and best solution. For the students, the opportunity to have a very real life experience and to have some information provided by the company with the possibility, the opportunity to touch and to see and to follow the process, I think it's a very very great experience to remember and to valorize in the future. After this, we have the quality control and assessment. So during and along the construction process, it's necessary to control day by day or according to the different steps of the planning, the activity. If the activities are carried according to the project, in order to verify the good realization of the renovation process. It is a typical activity of the construction phase, but again, thanks to the collaboration and to the interaction of the Living Lab, it could be very interesting to have a visual inspection, to have a instrumental verification, for instance, like thermography. So to detect during the activity of the installation, because sometimes the different step of the works is not possible to monitoring and to control, and then when the site are completed and the building retrofitting process are completing, we have no memory of the single step. So in this way, it's possible to have a collection of pictures, a collection of some documentation, and it's possible to correct. So if the team of the Living Lab is able to investigate and to identify some problem and some difference between the execution phase and the design solution, it's possible to introducing some comments and some correction. It's like a commissioning, so the activation of commissioning process is the best path to guarantee that the renovating building aspect all the requirements and reach all the target of the design phase, controlling step by step and controlling the real performance obtained. The research can support the building manager to achieve the target, so controlling, implementing the assessment, structuring the reporting activity, collaborating each other to define the quality report. The quality report is a very useful document describing all the history of the project. And this way it's possible then to evaluate if the experience could become really a best practice. So an example to replicate with the methodology in another context and to be described and integrated in the common platform as a very good experience to be replicated. Otherwise, the company can search and check the real performance the target and to evaluate if really the target has been reached or which is the gap between the proposal and the real realization of the solution. So in this way, it's possible to organize some activity to organize the delivery of the renovation, the renovated building. And in this way, it's very crucial to create some document like how to use, to create like a handbook or other elements more easier, like a data sheet, user manual, instruction, and so on, in order to have a checklist that is possible to check and to compile in order to evaluate step by step all the activity. In this way, it's possible again to evaluate in a very qualitative and quantitative aspect all the target that we propose in the phase 0. For the handover, how researcher can support, of course, with the data management, and the building manager receive and organize the handover documents. The company, they have to provide all the documents in order to be checked by the researcher in collaborating and supporting the building manager. So there is a very interesting circulation of documentation in order to implement the awareness of the company to do the best, to contribute to create a very good pilot building, as well as for the building manager to check and to control, and maybe to thanks the company or to support the good quality of the company with a good dissemination and a good advertising of the best practice. So it is a very positive circulation of the information, and it is a very positive activity, common activity. In this way, it's possible, starting from the knowledge framework till the construction and the monitoring of the construction phase, to transform the pilot building really best practice. And it is very important because in the next phase, it's possible to monitoring really the performance. So under construction, it's possible to create the little change before to define the project. Otherwise, when we monitoring the post management activity, we can search and we can demonstrate sometimes some mistakes that have done during the construction and the implementation of the project. So for this, it's very important to develop in a very best way with a very strong control. So implementing the control day by day of the building site, the company, with the company collaboration, because the last phase, it's really dedicated with the post management, and it is the main control activity, and to close all the process, demonstrating the real successfully activity of the pilot. In the last phase, we have some key topic activity, very interesting, and this is a very key rule. There is a very key rule of the living lab. Why? Because there are some activities not only at didactic level, but also creating some dissemination and some advertising aspect, where it's possible to publish and to have an enlargement of interest in the building site. But also it's very interesting to monitoring the real performance after the construction compared with the first target. How? Throughout some monitoring, throughout some sensor, throughout other specific tool, not only simulation, because we have done the simulation during the design phase. Now there is the verification of the idea, of the previous and predictive action that we did during the design phase. So where the new strategies and technologies have been integrated, now they're requiring a new ways of management to maintain the improvement of the performance over the time. So now we need to guarantee that the new performance are, of course, the best one, and will be during the real life of the building, every time in the top level. About the involvement of Living Lab, this is very particular, very interesting activity, because the building manager, they play a central role to support the innovation of the current practice, but especially for the research, they can support the adoption of new procedures, especially the collaboration of architects, engineers, energy engineers, information engineers, but also expert in user design, user engagement, service design. Now it is the moment to introduce some soft activity concerning the people engagement, the community engagement, the visualization of the result, and the demonstration, of course, the achievement of the target. And the company have a very high interest because they can provide innovative tools to do this kind of management of the renovation building. And for them, it's possible to test their solution. In this way, they have the support of university to underline the real performance of their solution. So it is an additional activity and they will benefit from this. For the students, it's very interesting to be engaged in the new life of the renovation building, assisting in this kind of transformation and feeling the interaction with the new activities. In this way, it's possible to foster their awareness. The new site, the pilot building that became a best practice is very important because can stimulate a new behavior of the student inside the university space. Because it is a good experience that they can test day by day, and they feel to be engaged in the new life of the renovated building. So there is again a positive virtual process between the end user, the behavior of the end user, the implementation, increasing of their awareness, and the real feeling that they have with the new performance of the building, because they can test now the comfort level of indoor space. It's possible to have again the questionnaire when they test and monitoring the quality of the solution. So again, they can compare the situation before the intervention and now in the new life of the building. So they can feel really very active in this evaluation process, verifying and measuring their involvement like a good tester of the intervention itself. And the public organization can be involved to valorize the experience, because as owner of the building, they can demonstrate, oh, wow, we are the best, we have the best pilot, we can implement a very good solution, our living lab is really active, so we have done a very good work. So again, the last phase is the more public, is the more didactic, but also is a very good dissemination, or like a testimonial, no? The building will become a pilot and a testimonial of the positive process and the benefit to have this kind of integration between the team, the multidisciplinary team, and the collaboration with the companies. So it is a demonstrator of the best part. The last one, the last activity is, it's not the last, sorry, but the monitoring. The monitoring is possible to integrate with the train of the community. In this way, the new best path will become a training path of the functionality, of the use, in order to support the end user to have a good behavior inside the building. So not only the acknowledgement of the new performance, how to interact in the best way, reducing the energy. So now the building is much more performant. It was possible to reduce the consumption, but which is my best behavior in order to support the good performance of the building. So which is the role of the end user? It's very important, this aspect, because the engagement of people and the engagement of students as end user will implement the benefit of the intervention and will support to have a very good optimization of the strategies of the project. So the physical building with the positive behavior of the people together will reach the target of quality, and especially the target of energy reduction, but also the good maintenance of the building. In this way, the researcher can support the organization of training path, so the implementation of didactic skill of the buildings, but also the capacity to engage the people, so they can define some service design activity to implement again the valorization of the living lab. The building manager can organize and deliver the training, and the student can participate. So there is a very good integration between researcher, student, and company also can support, providing know-how, providing some modeling scale, and some experience of the technological solution installed in the pilot project. And there is the time to involve again the public organization, but to enlarge all the community, creating a very good experience to implement the awareness of the people. So the pilot could be active to create a very good experience of this. About the operative and maintenance, it's crucial, because now that the buildings are retrofitted, how is possible to extend for much more time this kind of benefit? This is, of course, the activities of the not the company, because they stopped, they complete the activity, but now the public administration and also the end user have to have a good feeling with their building, and they need to contribute to maintain the physical aspect of the building. Otherwise, with their behavior, the real benefit and the level of performance inside. So in this way, the combination of mental and physical, so the operation and maintenance, as required to keep the renovated building and its energy system functioning at the peak, at the maximum of the performance. According to this activity, it's important to change the vision, because generally the operation and maintenance is related to the reactive action. So there is a problem, and then the company or the people involved in maintenance solve the problem or adjust when it's break, saving now something wrong, or adjust something that doesn't work. So it is the typical activity in the public building, no? The reactive solution of the operation and maintenance. The level, the upper level is the prevention. So programming some activity in order to avoid the adjustment or to retard the adjustment, or maybe sometimes plan some regular intervention in order to check if the plan is okay, all the fitting are okay. In this way, it's possible to have much more saving in a long term. But thanks to the Living Lab, again, it's possible to introduce another level of operation and maintenance. It is predictive. So thanks to the monitoring system inside the university building, monitoring the performance, but also monitoring the equipment, something is wrong, on when something doesn't work as the planning phase. In this way, it's possible to have like a dashboard when you have different alerts, and when it's possible to check all the system, all the envelope, the windows, the light system, and so on. So have a predictive action during the real life of the building. And in this way, the research can support providing innovative methodology to have a monitoring protocol or other sensor, other tool, creating some dashboard where it's possible to have a control, more user-friendly control, no? Visualizing the real level of performance of the different equipment. And the building manager are in charge, of course, of the operation and maintenance when they can take benefit for this, organizing the plans, but also creating this innovative tool that is possible to search by an application in the mobile phone, otherwise in the computer. So it is another level of monitoring and control system thanks to the software application, where it's possible to have a panoramic and an overview of all the dynamic of the building. So the monitoring activity will be based on the idea that it is not possible to manage when it is not possible to measure. So the simulation before and the monitoring after the realization will allow to have a real framework of knowledge of the building. And again, searching about the different level of the target. So searching about the level of indoor comfort, of the energy efficiency, and why not of the environmental impact that the building will reach. But also the monitoring activity will ensure a very good reaction between the level of renovation, the activity, so the investment that we did for the renovation process. And thanks to a very good maintenance and the prediction of maintenance activity, it's possible to verify the improvements. So it is again a new best path where it's possible to extend the benefit of the renovation action, to extend the benefit of intervention in order to allow to the building during the real life with the cooperation of the end user to reach the best target and to maintain the level of the performance for the long time. The researcher of the Living Lab can support to investigate and to apply the best monitoring system. And when I say the best, it's not only the more complicated, but maybe the much more user-friendly for the building manager and for the public organization. The building manager will draw up and manage the monitoring protocol because there are involvement in first line for the monitoring process. The student can visualize the knowledge thanks to the software, thanks to the visualization of the performance, the monitoring, all the sensor installed in the building. So day by day it's possible to compare, for instance, the external temperature with the internal level of comfort, or maybe the energy production if there are some integration of renewable energy, or for instance the heat gains, the passive heat gains, or the level of environmental quality in their classroom. So they have the knowledge and stimulating their positive and proactive behavior, for instance, opening the window or otherwise close the window, or changing their clothing, or have a positive interaction with the building in order to implement the reduction of the energy consumption. And this is the last slide, I think, for today. And we try to present in this 5 steps all the benefit to implement the Living Lab and to create best path for retrofitting intervention. I think we can stop here. I don't know if there are any questions for these 2 last phases.
So thank you very much, Professor Topatore, for your presentation regarding the last two steps. Sorry, the intervention and the post-management of the toolkit solutions that were developed in the Metacosur project. I wanted to ask, you mentioned that about the monitoring, that it doesn't have to be an excessive way, but it can be adjusted to the level of each, I think you mentioned, to the level of each municipality, yes, and the project manager. Do you think that it could be easier for a municipality or a public authority that is responsible for this kind of building to have a specific set of rules for the monitoring, or should we, because as you mentioned, it doesn't have to be an excessive program, has to be one that's most user-friendly. So in particular regarding the public authorities, because in our project we're also dealing with municipalities, so we have to adjust to their level of knowledge and their issues, and also the people working there and how they should select their specific buildings. Do you think that a public authority should follow a specific way of monitoring, or it should be adjusted based on internal factors, etc.?
First of all, monitoring is a state necessary. as you explain, and we will dedicate 1 or 2 lessons in the next day explain this. You can apply a monitoring protocol, but you can adjust and customize, of course, the feedback of the monitoring, so the visualization of the data, thanks to the platform, thanks to the new software, in a very user-friendly way. Because you can collect thousand data, and sometimes they are so specific. So it's very important for energy engineering to evaluate this kind of data, but it's very important to transform and to elaborate this data in a very friendly visualization, especially for the end users, especially for the not addicted, no? The people not involved in a very so sophisticated research level. So we think that we need a protocol for the monitoring. We need the installation of sensor. We need to create this kind of link between the real data, no? To search the real data of performance. But we'd also need to communicate, so customizing the visualization of the data according to the different target of people, target of end user, okay? And we will present in the next day our works about the monitoring protocol. The engineer Pierucci will present, I think next week, our protocol for the monitoring and all the sensors installed in the living lab and also in the building, as well as we will present the platform, the innovative platform, user-friendly platform that we are designing with our colleagues coming from the Department of Design, Service Design, in order to create a very user-friendly, very easy communication tool and didactic tool, and why not to implement the behavior of the people. So as I mentioned in the last slide, it's possible to search, oh, now the temperature is very high. Maybe during summer, instead to switch on the air conditioning, it's easier to open the window. Why not? Okay. So creating the opportunity for the end user to interact, no, for the good performance of the building. Not only
to have easier access to data, and also to
yes.
comprehend the data better in order to find solutions user-friendly. As mentioned, maybe opening the window.
Yes, perfect. You can use the data in a very high technological way to understand the performance of the building, but also to suggest a very easy behavior, no, of the people inside to implement good quality of the air. Sometimes it's easy to open a window. So it's very easy to have an alert, oh, the temperature is very high, maybe you can open the window instead to.
Yes, and as we have seen from previous presentation related to other projects as well, that the behavioral analysis on the building scheduling and the building processes from the end user can have an effect on the energy consumption, on the comfort, etc.
Absolutely, because the end user has to be active and proactive. So they need to be really integrated with the real performance of the building, understanding the dynamic of the performance of the building, introducing their positive behavior inside. So they need to be aware, and then to know some very easy solution that they can implement to upgrade the temperature, the level of comfort inside the building. Sometimes very easy solution.
Exactly. Sometimes even a small gesture can make a difference.
Yes, sure.
So thank you very much. And if there is no other question, I'm not sure if there is another question at this time. I think, as you mentioned, we can end the session here. And of course, next week we'll be also be
Yes,
continuing.
next week we investigate much more deeper the monitoring, of course, and then the communication, so the engagement of the end user. So this
Yes, and I
interesting,
just,
especially for the living lab, are very innovative action.
yes, and I just want to remind the participant that on Tuesday we have the presentation from MEDREC regarding the ICT platform of Medecosur, and that is in the morning, and that was moved from this week to Tuesday the 26th, and then no 25th, and then we will be having the Medecosur project as well, the University of Florence, Professor Dobadore and her team, regarding the outcomes and the monitoring and the other tools, more input and more insight regarding the processes. So thank you very much all of you for joining us today, and of course thank you Professor Dobadore and Dr. Gargano for being here and for inviting Professor Marco Sala in the first session. Hello, Dr. Gargano. Thank you very much for being here and
You're really welcome.
for joining our session. And of course, if the participants have any further questions regarding the session, we will be able to provide your contact information to further investigate any solution or any inquiry they have. So thank you very much. And thanks to everyone for joining us today. And we will be seeing you next week. And I hope we can continue all this fruitful collaboration. Thank you very much.
Thank you. Have a nice weekend. Bye.
Bye.
Thank you all. Have a good weekend. Bye-bye.
Bye-bye.